The Ender 3 multiverse is huge, with ultra-modified machines for speed, ones that can print using plastic pellets or chocolate, belt printing, laser engraving, motion system conversions, and it's been paired with almost every upgrade out there just because it works. So with $100 US, me and Mitsubishi Makes will be competing to see who can get the most out of their stock Ender 3 within the budget and ultimately score the most points overall, using a marking system based on quality, performance, reliability, and a few other things. One interesting variable though is that neither I nor Mitsubishi live in the United States, so our budgets are slightly different after a conversion. He gets around 140 Canadian dollars, while I get roughly 170 New Zealand ones at the time of writing. I can't exactly order from the US though, so it looks like AliExpress will be my best friend and money sponge. Let's get to researching and putting those coins to good work. The last thing I want is to have them tied up in all the wrong areas. While researching, let's discuss my methodology for choosing my upgrades. I've seen how far people can push the Ender 3's stock motion system, so new motors are out of the question. They're also too expensive, as is 48 volts, but something that could get the most performance out of the current motors. Well, that's what I'm looking into. I've got two stages in mind for this, but I can't share them just yet. From experience, the main limiting factor is extrusion. The stock extruder, Hotend, and honestly the lot of it are just as cost effective as Creality could make them. I've heard issues about heat creep, blockages, under extrusion, basically everything you can find on the All3DP troubleshooting article. It's there for a reason. There is one more easy upgrade we could do with just a simple print that will help with extrusion and overall print quality, which is direct drive. Compared to Bowden, which has this large stepper motor mounted on the Z-axis of the machine, we can have this small pancake stepper installed on the tool head itself. Sure, it adds weight, but since there's a 3:1 gear ratio in the extruder to make up for it, and the shear retraction benefits and reliability the system adds, it's a no-brainer and we can swap the large stepper motor for a smaller one. I have this on all of my machines. Three more things. Sometimes the bed on the Ender 3 can be a bit warped, so I'll grab a cheap BL Touch clone that should help us counteract that. Some strong 50-15 blower fans for a good deal of cooling, and no new build surface. I'll explain shortly, but I think that's research wrapped up. Now that we're waiting on the parts to arrive, let's unbox my new Ender 3 and get some baseline results. Everything looks sort of normal until you realize how much grease they've put on this thing. It is crazy. Easily the prettiest filament I've ever had. That could look better. A lot better. As you can see, the layers aren't very uniform. Maybe I should have gone for a dual Z-axis. I'll see what I can find in the parts drawers later on. There's quite a bit of stringing as well. Unlike the models printed by this video's sponsor, PCBWay, whether your requirements are flexible SLS printed parts, durable SLM printed parts, CNC'd or laser cut components, PCBWay has you covered and more. They have flexible order amounts, so it doesn't matter if you need one part or 100. They have super fast and reliable shipping, which I've been super pleased with, and if you want to see what they can do for you and your project, I've left a link in the description. Once again, the accuracy is good, but the layers, not so good. That's our baseline quality and speed tested. Now let's get to the upgrades. The CHC Pro Hotend from Triangle Lab is one of the best value high flow hotends you can get. It uses a ceramic coil for even heating and has a max temperature of 300 degrees. To pair with the Hotend, I've chosen a brass 0.6mm CHT volcano nozzle to get even more flow rate out of the system. And to eliminate heat creep, I've picked up a mellow bimetal Heatbreak. As for extrusion, this super cheap BMG clone extruder should do the job nicely at a crazy low price point, at least until the gears wear out. To drive it, I've grabbed a small pancake stepper motor to keep things mostly lightweight, but still capable. Better cooling is one of the most important upgrades you should do to your machine, so I think these 8500 RPM blower fans should work well. These are the most premium 5015 fans I've ever bought. Oh. Luckily, my original Axial fans that I chose should work fine, but will require other components such as a relay and voltage step-down circuit to work, which should put me over budget. To help with the pain of leveling, I've grabbed a cheap Bell touch clone, which should ultimately help with overall print quality and reliability. Finally, we have the SKR Mini E3 V3 mainboard, which will give us silent motor movements, more expansion options, and make the final upgrade a whole lot easier. I know nothing's changed for you guys, but I just spent the morning working on the Creality High, and that thing feels like a spaceship or an alien compared to this thing. Now I feel like I'm back in the Stone Age. I am missing one of these. I can't get through the fan. Oh, maybe I should have looked in the tool drawer. Specifically the tool drawer where I store my most used tools. Goodbye, weak little fan. Into storage you'll go. Banished. If I can do this tool head upgrade in one go, I will be extremely pleased. And that'll be a first. Specifically getting the tool head in one go. I am pleased. Sometimes. Goodbye, little hot end. Maybe it'll be smart of me to remove the filament first. Alright, that was a little bit harder than I thought, but we have removed the hot end and the part cooling fan, but we've kept the hot end cooling fan. Now we just have to install the new hot end wiring and we should be all good. The hot end comes with extensions for both the thermistor and the heater, so that's exactly what I'm going to install first. Thermistor and heater wires have now been routed. I'm not going to count it in the budget because honestly it's just wire, but this is a splitter and this is an extension cord, so now we can plug two fans into this up at the top of the printer and run this down the rest of the thing. Let's install that heat break into the heater block. And we should be able to just slide this new one in, just like that. It was that easy. I've temporarily wired in the heater and thermistor so that now we can install the nozzle and hot tighten it. I forgot how quick this one heats up. Love it. What surprised me the most is that this stock Ender 3 mainboard can handle 115 watts going through this block, considering the stock cartridge is 40 watts. It is easily one of my favorite looking 3D printer components. This is where things get a little bit interesting with the BL Touch. Wow, that was probably the easiest mounting sequence for a BL Touch I've ever had. And we'll just pretend that I added the cable during that because it's pretty awkward otherwise. I'll also install the heatsink fan. Having a plethora of different bolt sizes does make it super easy, but I guess I'll have to add $1 or so to the budget for all the bolts that I've used. Little problem, the screws I have are either too long or too short, so I'm going to have to install some heatset inserts. That is starting to look really cool now. That was a super easy install. I would use the step motor that came with the machine for the extruder, but the problem is it has this pressed in gear at the top, so I can't use it. If I take it off, it's a clean shaft. If I cut it off, it is an O shaft instead of a D shaft, I believe. Oh, wait, before I do that, we got to install the PTFE tube. I'm just going to switch it for a clear one. Ever since I bought a dedicated cutter, things have been getting so much easier. Honestly, buying the right tools for the job is the best decision that I've started making. No slack, I got it absolutely perfect. That's nice. This is probably the easiest whole tool head upgrade I've ever done. Oh, and just in case I get a comment or two about it, I'm aware that this extruder mount is in PLA, and yeah, that's not the most heat resistant material. I don't have anything else at the moment, so we'll swap it out some other time. Oh, I pulled this through the wrong way around. Fixed it. Now we can tidy up the cables. I'm sure some of you are thinking it, where is the dual Z-axis? Well, maybe if I had cheaper fans, like cheap 5015 fans, and I got rid of the BL Touch, dual Z would be a much better option, but I'm sticking with this for now, and we'll see how it goes. The Ender 3 that's currently the, I call it the Limits Ender 3, is I think I bought it 5 years ago now. Come on. Come on. Somehow I got the dimensions for this case horribly wrong, so I'll just have to chuck all the components in there for now and design a better version later. That's all good though. What on earth was I doing? I'm more embarrassed than upset because I was actually trying to do a good job this time. But could be worse, I guess. All the components still fit in there, I just make sure they don't interfere with each other. Alright, I've got the 24 to 12 volt step down converter and the relay hooked up to this connector so that when we want to install the fans, where is the fan connector? Here it is. This runs straight to the fans as done before, and now they'll get 12 volts with a relay and a step down converter instead of 24. Not bad at all, not bad at all. If we remove the actual connector from the terminal things, we can run them through the side of the chassis like this and have it go through the main board instead of the back of the machine. It's much cleaner. There we go. That's our whole fan system set up. Now, there is one really important detail. On here, you can see that it says 270 watts. I thought that was the power supply wattage, but I believe the power supply is 350 watts. The reason that this is important is because the heated bed draws, where does it say? There it is. You can see behind there, 220 watts, and the hot end is 115. That's already over 300 watts. So if this was any weaker, we'd have a problem. We should be all good, but yeah, I'm gonna look into it and be careful. The reason I'm using a, what is that? The reason I'm using a USB buck converter to power the Raspberry Pi is because I want it to have as much current as possible, rather than risk damaging the main board by drawing too much from it, even though it's a Raspberry Pi 02W. It's a bit of a mess, but I've completed the UART wiring and the 5-volt power for the Raspberry Pi. And you can see in there, I've wired the TX and RX pins to the RX and TX pins on the main board. That's going to be a bit of a pain to get set up, but we should be all good. I am going to go clear up the workspace now. Much better. Awesome. Okay, now we need to do a power on test and hope that nothing has gone wrong. All right, this is a little stressful after all this work. The BL Touch should probe. Raspberry Pi light should turn on. 3, 2, 1. That's good. That's turning on. The fan's not spinning. Well, yeah, that turns on when the hot end is turning on. Never mind. That's great. That's great. All right, I'll see you guys in a little bit once I've got the UART Raspberry Pi hooked up to the main board with Clipper.
2 days later.
We got UART mode working, we got Clipper installed. Now I just have to get the configuration set up and also install the version 2 parts, which I'm printing currently. I had some wiring issues, but now, check this out. Yeah, that's good. Here I'm tuning Input Shaper with a BigTreeTech S2DW accelerometer to cancel out printer vibrations, which will let us push speeds without excessive ringing. Though with how far I push this machine later on, ringing will appear. This will help us squeeze every drop of performance out of this machine, so if you can only do 1 or 2 upgrades, I'd highly recommend Clipper and Input Shaper. If you've been watching the channel for more than 2 years, you'll know that this is a build tack sheet, but underneath it is a G10 sheet. Makers Muse and a few other guys did videos on these, and of course I did one over 2 years ago, long time now, but they are amazing. And since we can't afford to buy a new build plate, this will do just as well. There's nothing wrong with build tack, this is just better. Actually, it would look a lot cleaner if I removed the stickers. I'm gonna do that, yeah. Sub 10. That's 5 times faster than stock. 5 times faster. Let me label this and then we can look at it. Alright, this is the 942 Banshee. You can see it's still got the artifacts that stock had, but it's actually a little bit better. There we go, we can see those layers under the light. Struggles a little bit with the bridging, and the smokestack was a bit too quick, but let me grab the stock one. Here's stock on the right. I'd say that's within a, 10-20% margin for me to call that a success. I mean, this is 5 times faster, 10 minutes versus 50. That's mad. Yeah, it took a while to get here too. Had all of these prototypes and several failed ones. There is notable ringing on the fast Banshee, but yeah, I think we could iron that out. At the start here, we've got a 50-minute one, and then it shifts over to 14 minutes, 13 minutes, and then all the way at the end there we have our sub 10. However, we do need to print a few other things, just a few Banshees ain't gonna cut it. Actually, I do want to print one more, but a lot slower. These are all of them side by side. Can you tell which one is which? I know the middle one is stock, but I actually don't know which one is. I think that's the speed one, the sub 10, and this one here is sub 12. Yep. I'm so pleased with that. Stock motion system, just upgraded extrusion and software can really net you some benefits. It's so cool. This one took 11 minutes 10 seconds, this one took 11 minutes 3 seconds, and you can see where the Z-banding happened. So that's why I put the model on the left side of the bed to eliminate that. The main thing is the cooling is good, which is good because we can't change that, and all the other issues can be solved with some more calibration, which checks out. I kind of didn't do any. Something's off. I don't know if that, I think that's pressure advance being all weird. The one on the left took 10 minutes, the one on the right took 40, so I'm not too fussed. I'm actually pretty impressed with how well the speedy one printed, despite the ringing being pretty visible. Right around now was when I spent a considerable amount of time tuning pressure advance, trying to get it to work, trying different things to eliminate more vibrations, and ultimately trying to get the most quality out of this machine. Well, I think ultimately this one turned out worse. It did do better on the dimensional accuracy with all of these pins here, but the retraction was actually worse despite me increasing the numbers even more, and the top surface could do with some more tuning, but I'm all out of time for that for now. If you're still wondering why I did all of this, well, it's because I can. Not every machine out there is hardware and software open source like the Ender 3 and Clipper, and it's a nice touch not having to worry about firmware updates blocking my prints. This concept is for those with an old Ender 3 in their garage sitting around and collecting dust, not those with a shiny new smart machine on their lounge table. Not bad for a 7-year-old machine with a stock motion system, although I still wish I could have done better. Still, if you guys would like to see what another $100 could do for this machine, let me know. Mitsubishi unfortunately ran into some issues near the end with his machine, possibly compensating for my good luck with mine, but he has recorded a tour of his, so let's check it out.
Hello everybody. As you can see here, this is my Ender, but it's not exactly in a working state. So let's talk about this. Overall, things are actually going pretty well. I'm super happy with this tool head. I have a monstrosity of a Hotend in there, held together with a paper clip, dual heaters running wired in parallel. I got to experiment with making my own silicone socks and also silicone bed spacers out of RTV silicone. Kind of a fun side quest. But in the end, what ruined me was unfortunately the firmware side of things. Could not get that to work for the life of me, but then I started having issue after issue after issue with the boards. So I'm starting with the stock board. I could not get the firmware to flash on this for the life of me. I tried a bunch of times, could not get it to work. So when that couldn't work, I had to sort of bite the bullet and go with an upgraded board, but still no luck. Finally, in a last-ditch attempt, I tried to pull out the old SKR Mini E3 RRF, could not get it to work. I actually had different issues with all three boards. I'm bowing out, and Tommy wins. Congratulations, Tommy. And it's unfortunate, but that's sort of how it goes with these sort of things. Especially true when you're working on a deadline. And poor Tommy's had his Ender finished for over a week now, and I'm just floundering around with all this stupid firmware stuff. So in general, I do think this idea has some pretty major promise. Just talking with Tommy and seeing his results on the stock motion system, I think all you really need is a nice tool head, and you can get some insane results with an Ender. So I don't want to abandon this idea of like really budget conscious upgrades for old printers that a lot of people probably just have around collecting dust. All right, back to you, Tommy.
Since we're wrapping up, this is what I think my machine deserves for a post-upgrade ranking. If you guys would like a part 2 or have any suggestions or questions, please let me know. But for now, thank you so much for watching, and hopefully I'll see you again soon.